Hello everyone, my name is Max Hils. I'm a PhD student at the University of Innsbruck in Austria. Today I present joint work with Daniel Woods, who will be joining me later, and Rainer Böhme. In our paper we look at the past, present and future of privacy preference signals. If we go back to the 2000s, some of you may remember P3P, the platform for privacy preferences. Arguably, this was the first major privacy signal on the web, delivered with a simple protocol between website and browser. It was recommended by the World Wide Web Consortium in 2002, but ultimately failed due to a lack of adoption. A bit more recent, if we look at the 2010s, many of you will remember Do Not Track. This standard had a much simpler design with a single switch in the browser. Unfortunately, there was some controversy on the default setting of that switch. As a result, ad tech companies decided to withdraw from the initiative, and this privacy signal failed as well. Today we have something many of you are very familiar with, GDPR cookie prompts. These consent dialogues are often based on the TCF, the Trust and Consent Frameworks. The dialogues claim to capture your privacy preferences and share consent decisions with third parties. While the example here may look simple on the surface, we shall see that the underlying privacy signal is actually quite complex. The fact that you see these dialogues everywhere on the web actually suggests widespread adoption though. In the paper we ask, why is this particular signal so successful, and what can we as the community learn from that? In this presentation, my co-author Daniel Woods and I take you on a time travel. Daniel will first look at past signals. Then I will zoom into the TCF and present our web measurements, and finally Daniel will take a crystal ball and make some predictions on the future. Those concern the upcoming GPC signal as well as more general lessons learned. Daniel, now it's your turn.
So privacy preference signals are digital representations of how users want their personal data to be processed. Signals must be adopted by both senders and recipients. In this case, senders are users and recipients are ad tech firms and websites who process personal data. Such signals are intended to influence how entities, including websites and third parties, process personal data. These signals vary from a binary do not track through to the more complex expressions seen in cookie consent dialogues. And adoption represents a coordination problem because there's no sense of senders sending a signal when no recipients have adopted it, and equally, there's no sense in recipients adopting a signal that nobody sends. So, efforts to standardize a privacy preference signal go back to the late 90s. Ad tech vendors and privacy actors alike participated in the World Wide Web Consortium's working group. It provided a way for users to express preferences that could be compared with website privacy policies. You may also remember this little green bird, the P3P's mascot. In 2002, the P3P specification was recommended. From a technical perspective, P3P describes an XML format to encode a human-readable privacy policy into a machine-readable specification. Users can define individual privacy preferences which a user agent, like a browser, can cross-check against a website's self-reported P3P policy. Unfortunately, it was only adopted by one browser, Microsoft, who gave websites with misconfigured policies a free pass. This meant that vendors and websites had no incentive to honestly express their privacy policies. 5 years before the P3P was eventually obsoleted in 2016, the World Wide Web Consortium again launched a working group, this time to standardize the Do Not Track mechanism. From a technical perspective, Do Not Track was much simpler than P3P. If a user enabled Do Not Track, their browser would send a simple Do Not Track header equals to 1 with each HTTP request, signaling that they do not want to be tracked. Do Not Track actually received widespread adoption among browsers, with even Google reluctantly adopting it. However, websites and vendor adoption was negligible, and the Internet Advertising Bureau famously withdrew from the working group after Microsoft announced that the signal would be turned to on as default. The World Wide Web Consortium's working group wasn't actually closed until 2019. In the meantime, AdTech had begun to work on an alternative signal.
Welcome back to the present. While Do Not Track lacked the legal basis that could have forced AdTech to participate, the signal we are seeing on many websites today touts itself as a standard built by the AdTech industry for the AdTech industry. More precisely, the Interactive Advertising Bureau has developed the TCF as a reaction to the GDPR, the General Data Protection Regulation in Europe. The first version of TCF was published in 2018, and since spring 2020, we are at version 2. While everyone has seen these dialogues, the underlying standard is much less known. One reason for that is that TCF was developed by a subset of the community. While the World Wide Web Consortium followed a multi-stakeholder approach with P3P and DNT, the IAB exerts quite some control over TCF. They decide who can join the working group, who can collect signals under the standard, and also which AdTech vendors can receive TCF signals. P3P was quite complex, then DNT proposed a much simpler approach, and now TCF is a very complex signal again. However, a key difference to P3P is that TCF does not require adoption by browsers. Websites implement the consent dialog directly, which means that the browsers have no say in the design of the signal and its user interface. Let me come back to our claim that TCF is a complex signal. I've also shown you this dialog before, and you may be tempted to say, well, there are 2 buttons here. This looks rather simple. Well, there's actually much more complexity hiding behind this More Options button. Below the initial surface, you can find a list of specific data processing purposes. And you can also find a list of the 600-something vendors participating in the framework. Additionally, the TCF standardizes specific legal bases under which vendors may process personal data. Let me give you an idea what that means. If you want to exercise all privacy options available to you, clicking Reject All is actually not enough. You also need to go to the Legitimate Interest section down here, then manually object to everything on the screen, and only now you have actually opted out from all tracking. That is, of course, a bit ridiculous, but from a research perspective, it is interesting to study how websites and vendors alike make use of this complex standard. The empirical part of our paper analyzes the adoption of TCF with a novel combination of data sources. Since we described our measurement methodology in a separate paper published at the 2020 Internet Measurement Conference, we only want to give you a rough idea of our datasets here. First, we use Netograph to obtain about 7 million captures of websites embedding consent dialogues that implement the TCF. This data is longitudinal and goes back to early 2018. It allows us to observe at which point in time which website adopted TCF. The second data source is a snapshot crawl of the top 100,000 websites in the Tranco top list as of February 2021. For this measurement, we use customized browser instrumentation to directly interact with the TCF JavaScript APIs. And finally, third, we also use the historic versions of the TCF vendor list. All AdTech vendors who want to receive the TCF signal need to register on this list and pay a fee to the IAB. Now, coming to our results, I would like to leave the logistic regressions in the paper and show you some high-level results here. In this figure, we see the adoption of TCF by AdTech vendors over time. On the left, we see the adoption of TCF version 1 in 2018, and then the steady switch to version 2 throughout 2020 in green. Observe in yellow that some new vendors joined version 2 directly. I would like you to pay attention to 2 things in particular here. First, we can see a massive adoption of the signal right after it was announced in April 2018, which was shortly before the GDPR came into effect. Second, if you look at around August 2020, we see that the vast majority of vendors had switched at this point. These 2 points in time are very interesting to contrast against websites' adoption behavior. Let me keep the red frames here and replace the time series behind. Now we see a different picture. First, the ramp up in 2018 is much slower. When GDPR came into effect, almost no websites were using the TCF signal yet. Likewise, if we look at August 2020, we see that only half of all websites had switched at this point. Our reading of this is that ad tech vendors had been driving the adoption both for the initial version and the switch to version 2. While 2 instances provide some confidence, we can support this conclusion with micro-level evidence. For this, we analyzed the factors that lead websites to adopt TCF. For example, websites that embed more third parties are more likely to adopt TCF. This supports the argument that a standard helps to coordinate many parties. An additional driver could be websites' reliance on advertising revenue. To test this, we select one specific third party, namely Google Ads. What's interesting about Google is that it did not adopt the first version of TCF, but joined at version 2 in 2020. Now, of all websites which now support TCF2 and not use Google Ads, 60% had already joined TCF version 1, whereas this applies only to 45% of the websites using Google Ads. One plausible interpretation to me is that the website's boost of TCF adoption is directly related to Google's adoption of TCF. Let me summarize the picture our data paints today. Our measurements show that TCF has been adopted by hundreds of ad tech vendors and thousands of websites. Meanwhile, P3P and DNT are history. So, is TCF going to rule the web? Not quite. There are all alternative signals on the horizon. Turning to the future, I will hand over to Daniel.
The global privacy control was defined in an unofficial draft specification in October 2020. It continues the approach of Do Not Track in that it extends HTTP requests with a single bit value. But most importantly, the signal's specification now directly references the Do Not Sell clause from the California Consumer Privacy Act. Now, rather than collect preferences by embedding dialogues in web pages like TCF, under the global privacy control, privacy preferences are collected via user agents, like for instance browsers or browser add-ons. Thus, user adoption decisions are in effect made by browsers. This means that GPC adoption will be adopted in leaps as each browser adds support, rather than in this kind of slow trickle which we just saw, in which thousands of websites adopted the transparency and consent framework. So, for example, the GPC website now reports that over 40 million users are currently utilizing a browser or browser extension with GPC support. Now, interestingly, the specification creates the possibility for websites and ad tech vendors to publicly advertise that they support the signal. This makes a web scraping adoption study possible for future work. So, privacy preference signals, like for instance P3P or global privacy control, are collected once via a user agent, and they apply across the entire web. In contrast, TCF signals apply to just one website, or at least they're collected by a single website, and they expire after a period of time. And a cost is actually paid for this, because websites must show this dialogue, and that takes attention away from content which users enjoy, and it takes time away from adverts which generate revenue. We actually estimate in the paper that 2,500 years of user time was spent sending TCF signals. So this is a huge opportunity cost. And why is it accepted? It's because ad tech vendors want to claim that user consent was real and autonomously collected. And the flip side of this, we anticipate, will be used as a critique of privacy preferences that are stored in the browser. This is particularly true if the preference defaults to opt out. For example, already we see that the Privacy Badger add-on turns the GPC signal on as a default without collecting preferences. Now, to some extent, that's justified because this is a kind of pro-privacy add-on, but then we anticipate that ad tech vendors will kind of critique this. Especially because we saw with Do Not Track that the Internet Advertising Bureau withdrew from the working group after Microsoft turned it on by default. Another area where nudges are controversial is in interface design. So there's a huge body of work looking at dark patterns, and that, for instance, will focus on the fact that most dialogues will have a one-click accept all, whereas opting out requires multiple clicks. So here again, we see how nudges that nudge users towards expressing certain preferences become very controversial. This actually led an NGO, None of Your Business, to issue automated warnings to websites deploying non-compliant dialogues. It's unclear whether these complaints and surrounding regulatory action will actually threaten adoption of the signal, or even whether they will change the design of the dialogues. So, our final question that we'd like to leave with you is whether one global privacy preference signal will emerge. And we see two barriers to that. The first is that two contradictory signals can be simultaneously sent. You likely noticed that GPC signals are sent as HTTP headers, and TCF signals are sent via JavaScript in the web page. So users could very plausibly send an opt-in TCF signal through a browser with an opt-out GPC header turned on. Thus, we do not expect one standard to definitively emerge, like, say, VHS did over Betamax. A different barrier is this trade-off between jurisdictional specificity and signal complexity. The GPS is a tremendously simple design in the specification, but it very specifically references a clause in the California Consumer Privacy Act. But in doing so, in having a simple design that's very specific, the problem is the signal now has a less specific interpretation in other jurisdictions, for instance in other states or even international privacy laws. So maybe instead of having just one global privacy preference signal, we will actually have a series of signals, each referencing a specific privacy law. So, to conclude the talk, it's worth noting that for more than 20 years, we've now seen tremendous effort invested in privacy preference signals. The fundamental problem is coordinating adoption between senders of the signal, users, and the intended recipients, ad tech vendors. Past signals were largely ignored by ad tech vendors who had no reason to receive the signal, especially as there was little regulatory involvement. In contrast, ad tech vendors rapidly adopted the transparency and consent framework, and by 2021 it had become the dominant signal. The timing of adoption suggests GDPR coming into effect was a key driver of adoption. We also presented evidence that business relationships help explain which websites adopt TCF. So, looking to future work, it is not clear that TCF will be the dominant signal, or even whether a dominant signal can exist. We should thus expect a future of coexisting privacy signals with each referencing a different legal basis and jurisdiction.